Rational functions. So today we're just going to go through a lot of rules that we'll be able to apply. So a rational function, f of x, is the quotient between two polynomial functions. So I've written an example down below where we have a of x in the numerator and b of x in the denominator. So a of x is its own polynomial and b of x is also its own polynomial. What's important is that b of x has to be a non-zero. So we can't have a zero in the denominator because then the entire function would be undefined. Rational functions can have vertical and horizontal asymptotes as well as oblique asymptotes. Oblique asymptotes are slant asymptotes. Remember, an asymptote is a line that the graph approaches and it helps shape the graph. We're going to go step by step and come up with rules to identify all the different types of asymptotes. So a vertical asymptote occurs wherever the denominator equals 0. So to find vertical asymptotes, we set the denominator equal to 0 and solve. So in our example, it's wherever b of x equals 0. Where b of x equals 0 is a vertical asymptote because it means that it's undefined at that point. Horizontal asymptotes mean that we look at the degrees in the numerator and the denominator, and then we follow a set of rules to identify where the horizontal asymptote is. There can be at most one horizontal asymptote. So here is our function. I'm going to use some new notation, n and m. N stands for the degree of the numerator, and m stands for the degree of the denominator. Then we're just going to compare those degrees and follow a set of rules. So if the degree in the numerator is less than the degree in the denominator, the asymptote is that y is equal to 0. If the degree in the numerator is equivalent to the degree in the denominator, the asymptote is actually an equation where we use the leading coefficient of the numerator over the leading coefficient of the denominator. And if the degree in the numerator is greater than the degree in the denominator, then the asymptote does not exist. So there's no horizontal asymptote. You're going to need to have to remember these rules in order to sketch a rational function. Steps to graphing. So for the first step, what we're going to do is we're going to factor if necessary. So factor the numerator, factor the denominator. Then we're going to identify all vertical asymptotes. That's my shorthand for vertical asymptotes. So remember, we're going to set denominator equal to 0 and solve. After we do that, we're going to use where those vertical asymptotes are, and we're going to identify the domain. Vertical asymptotes and domain go hand in hand. Then we're going to find any horizontal asymptotes using the rules that I just outlined above with the degree of the numerator and denominator. We're going to find x and y intercepts. So as a reminder, to find the x-intercept, we set y is equal to 0, and to find the y-intercept, we set x equal to 0. The last step is we're going to make a table and graph.